A trapezoid is a quadrilateral that has exactly one pair of sides that are parallel. So the other ones cannot be parallel, otherwise it won't be a trapezoid. So this one's just a normal trapezoid, nothing special about it. But you have a base 1. There's two bases, so this would be base 1, this will be base 2, and then we also have the perpendicular distance from base 1 to base 2. That is the height. So if we wanted to get area, the area of a trapezoid, we'd have to have a formula. So the area is the same thing. It's kind of like a triangle, 1/2 times base times height, except for you add both the bases together. Like 1/2 times base times height, you just add the bases together. So that's how I think of it. That's how I remember it. If I wanted the area for a parallelogram, I should have said this in the other one, but its area is just like that of a rectangle. It's just base times height. We're going to be using a lot of Pythagorean theorem for this. Of course, the perimeter for a trapezoid just involves adding up all the slants and the bases. So the perimeter is just adding all those up. And let's take a look at an example. So we got that trapezoid, and let's look at an example. All right, let's take a look at this example. It's kind of crazy, but once you draw a picture, it's not so bad. The length of a rectangle is 7 more units than the side of a square. And the width of a rectangle is 7 less than the side of a square. You know what? I'm going to stop right there, and I'm going to start drawing a picture because I don't know what the heck it's talking about. But it says some rectangle, so I'm going to draw a rectangle. And I don't know the dimensions, but I'm just going to draw some rectangle. I know that these are right angles because it's a rectangle. And then it also says, it talks about a square. So I'm going to draw a square. So I got my square there. Kind of a square, whatever, close enough. And it says the length of a rectangle is 7 more than the side of a square. So I don't know what the side of the square is. I'm just going to call it x. That means this is x, and x, and x. And then the length of a rectangle is 7 more than the side of the square. So this means the length is x plus 7, and the width of the rectangle is 7 less. So that means this is x minus 7. Great. That's easy enough. If the area of the square is 54, well, that's easy to calculate. Just base times height, just x squared. X squared, that's the area of the square. And they said that equals 54. So if I square root that, square root both sides, I get x equals the square root of 54. Normally plus or minus, but we don't need to do that right now because we're talking about these positive distances. So x equals the square root of 54. If the area of the square is 54, the x is the square root of that. I guess I could simplify. What is the area of the rectangle? I'm gonna simplify this. Actually, I'll simplify it at the very end. The area for the rectangle is just the width times the length. So what I'm going to have is, well, I'll plug in the square root of 54. Square root of 54 minus 7, whatever that is, times the square root of 54 plus 7, whatever that is. And I'll just FOIL. So this is great. I get regular 54. Oh, come on. And then I have plus 7 square root of 54. I know these are going to cancel out because these are like conjugates. So that was that part. And now I'll do negative 7 times the square root of 54. Yeah, those cancel. That's why I did them in red. And then I have minus 49. So the area ends up being 54 minus 49. Well, that's really, really easy. It's just 5 there. So what's the area of the rectangle? It's 5. Everything comes out nicely. So the key here was to draw that rectangle. Some people are thinking like, wait a minute. The area, it's like these are so different. Actually, no, they're not that different. The square root of 54, that's going to be a little bit more than 7. So it's not actually that different. But if I say, I'm going to calculate it right now. If I have the square root of 54, that's approximately 7.348 units squared. So the lengths, or I mean the areas are actually pretty close. The area of the square is bigger because this is like shorter, probably like a lot shorter than I actually drew it. But there you go. Draw the picture first. A lot of the problems involve drawing a picture, and then you can actually figure it out fairly simply.